Hello, today we're going to learn how to solve a system of equations using substitution. So go ahead and set up your C notes in your notebook. A system of equations in 8th grade consists of two equations, and you're trying to find out where these two equations, when graphed on a line, are going to meet or cross. So for our first example, we're just going to choose two fairly basic equations. The first equation is y equals negative x plus 24. So you can see it has a slope of negative 1, and it crosses the y-axis at positive 24. The next equation is y equals negative 5x. So this is a proportional equation. You can see that it has a slope of negative 5, and it goes through the origin, or it crosses the y-axis at 0. Now we can tell that this equation has one solution because they're in the slope-intercept form, y equals mx plus b in both equations, and we can tell that the coefficient on x, or the slopes, are different. That means that they will eventually cross because they have different slopes. Remember, if they have the same slope, they will never cross because they are parallel lines. And if they have the same slope and the same intercept, that means that they are the same line, so they cross at all points. So it's infinitely many solutions. But we can tell that there's only one solution here. So for substitution, we are just going to substitute what this equation solved for y is, and we're going to put this in for y into this equation. As a reminder, if they're not solved for y, you can solve for either variable, but I always suggest solving for y. So we're going to set up our equation like this. We're going to put this value for y into this for y. So negative 5x equals negative x plus 24. Now this becomes an equation where we solve for x, where we have the variable on both sides. So I always move the one with the smaller coefficients. So remember, I need to do the opposite operation, so I'm going to add x to both sides. And on this, negative 5x plus x is going to give me negative 4x. 24 over here. Divide both by 4. You get x equals negative 6. Now you might think you are done, but you are not. Okay? We only know the x value of the point. Remember, we need a x coordinate and a y coordinate. So we're going to take this and we're going to put it back up into one of our equations. Now I'm going to choose this equation because putting this negative 6 into this one seems easier for me. Y equals negative 5 times negative 6. So y equals positive 30. Now my answer is going to be written as a ordered pair with a x-coordinate of negative 6 and a y-coordinate of 30. So at the point negative 6, 30 on this graph, that is where these two lines cross. Let's try a slightly more difficult one. The system of equations for this one is going to be negative x minus 3 equals y, and negative 3x minus 8y equals 4. There are two ways to do this. This one's already solved for y, so I can simply put this whole thing in here for y and then solve for the x. Or I can solve both equations, put them in slope-intercept form, and do the substitution then. I'm going to show you how to just substitute this value into y without putting this one in slope-intercept form first. So I'm going to rewrite this. It's negative 3x minus 8. Now, this is y. So as a reminder, I'm going to be substituting this in for y, so I'm going to put that in parentheses, and I'm going to finish off equals 4. Okay, so instead of putting y here, I'm actually going to substitute this value in for y, because I know what y equals. Y equals negative x minus 3. Now I need to solve for x. The first thing we need to do is distribute. So this doesn't change, negative 3x. So negative 8 times negative x is a positive 8x. Negative 8 times negative 3 is a positive 24 equals 4. Continuing to solve for x, negative 3x plus 8x is 5x plus 24 equals 4. Now that I have all my like terms combined, I'm going to isolate x. So first I need to subtract 24 from both sides. 5x on this side. Negative 20. And x equals negative 4. Now remember, we're not done. We have to take this and we have to put it back up into one of the equations. And I'm going to go ahead and choose this one. That looks like the easier equation to me. So I'm going to put x equals negative 4 up into this. Now, careful here, this is a negative x. So when I write it, I have to do negative and then put my x in, which is negative 4 minus 3 equals y. The reason we did this, remember, this is a negative 1 times x. So if x is negative 4, we still need to make sure we multiply that by the negative 1. Okay, so negative 1 times negative 4 is going to give us just 4 minus 3 equals y. 4 minus 3, of course, is 1 equals y. We're still not done. Remember, we need to give an ordered pair. So my x coordinate is negative 4 and my y coordinate is 1. The keys for the method of substitution is to make sure that you solve at least one of the equations for a variable. In this case, they were both solved for y, so we simply put them together like this. In this case, one of them was solved for y. That was nice. So we just substituted this in for y, and we didn't have to change this equation. Of course, you could if you wanted to. Then you solve for one of the variables. Then you have to put this back in to one of the original equations to solve for the second variable. And then you need to make sure that you write an ordered pair. Thank you.